Alright guys, here's a video for you for your Unit 6 review. We finished the unit this Wednesday, yesterday, and I really want you to be successful. So I'm making this video for you to go over your review packet to make sure that your answers are correct. And so you can be prepared for the quiz tomorrow, which is going to be Friday. And you'll be prepared to go over during the 3-day weekend to review your review packet and review your worksheets and be prepared for the test next Wednesday, okay? So right after the 3-day holiday, you'll come back and you'll have a statistics test. That's the Unit 6, all right? So let's go ahead. I'm going to try to do as many as your homework as possible here. I cannot do all of them, but I'll do quite a few, okay? So number one, first of all, let me zoom in a little bit more. Okay, there we go. Hopefully it's good for you to see. You should have this worksheet right in front of you as well. Okay, so this is the Unit 6 review. Now let's take a look at it. We started already with a histogram, okay? A histogram, and let's see what the numbers are representing. We really have to read the histogram before we even read the questions. This is hours volunteered at the animal shelter. So how many hours are volunteered at the animal shelter, and it's per month. And these numbers from 0 to 9 here is the number of volunteers. So how many people volunteer? So 0 to 9 people. I'm going to write people. So these are the people that volunteer. And here says is the time in hours. So it looks like that from 0 to 2 hours, 7 people volunteer. And from 3 to 5 hours, let's see how high it goes, 6 people volunteer. So now I know what the graph is telling me. Okay, so now that I understand what the graph is telling me, I can go ahead and answer the questions. It says how many total people volunteered at the shelter this month? So everybody that volunteered. Let's see. From 0 to 2 hours, we got 7 people. So 7 plus, from 3 to 5, we got 6 people. So plus 6 plus, from 6 to 8 hours, we got 8 people. So I'm just adding all the frequencies. 7 plus 6 plus 8 plus 7 again plus 5. Okay? So I'm adding up all these numbers of people that volunteer. 7 people volunteer 0 to 2 hours. Then 6 people volunteer 3 to 5 hours per month. So I'm just adding all the people together. And if you add this in your calculator, 7, 7, 14, you get 33. Okay? So if you add this in your calculator, you get 33 people. Okay? 33 people volunteer total. Okay? Now it says, how many volunteers worked less than 6 hours? Less than 6 hours. Okay, so here we go. These are right here. If you got to this bar right here or higher, you worked 6 hours or more. He wants less than 6 hours. So less than 6 hours would be these 2 bars over here. The people that work 0 to 2 hours, there's 7 of them, plus the people that work 3 to 5 hours, there's 6 of them. And that would equal 13 total people, okay? 13 people volunteer less than 6 hours. Okay, now I'll let you do this one on your own because you understand how to read the graph. All right? Now let's move on to the next one. Which measure of central tendency, mean, median, or mode, is most affected by an outlier, and why? So I told you that an outlier is a number that stands way out. Okay, so outlier is a number, I'm going to put just abbreviation, is a number that sets out from most of the data, okay, of the data set. So an outlier is a number that is really far away from the rest of the data set. If I had the numbers 1, 2, 3, 4, 5, and then all of a sudden I have 57, that's an outlier. It's a number that is way out from the rest of the data set, okay? Now, if I am trying to figure out which of these 3 measures of central tendency most get affected by an outlier, let me show you an example so you can understand. If I had the number 1, 2, 3, 4, 5, and 37, okay? I know that 1, 2, 3 on the bottom half here, and 1, 2, 3 on the top half. This would be my median. So this number really doesn't affect my median that much. Okay, if I remove the outlier, right now the median is 3.5. Okay, the middle number. If I remove the outlier, then I would have to remove down here, the median would be 3. Okay, so the median, the middle would be 3. So that didn't affect that number too much. I went from 3.5 to a 3. But guess what? If I find the mean, which is the average of all these numbers, it is going to be a little bit higher average because of the 37. But if I remove the 37, the average is going to be way lower. Okay? So the measure of central tendency that gets most affected by an outlier, it's not the median. Okay? The median gets a little bit of an effect, but not that much. The mode is just the most often. So the outlier really doesn't affect the most often number. The outlier affects the most is the mean. So the answer for this question would be the mean. Think about it. If you all had a 90% on the test, most of you had 90s, 91s, 93s, and then someone got a 2% on the test. That person just affected the average of all the tests, okay? So that's what I want you to think about. An outlier affects the mean or the average the most, okay? All right, number 3 here. Number 3, it says, for the box and whisker plot, identify the following. What is the minimum? Well, the minimum is this value right here. That represents the minimum. What is the quartile one? Is the bottom of the box. That's my quartile one. The medium is the middle of the box. That's my median. Quartile 3 is this value right there, the top of the box. And my maximum is this number right here. Okay, so I'll let you get those values by yourself and put them here. Now, remember, quartile 1 represents 25%, 1/4. Okay, quartile 1, 1/4 represents 25%. Quartile 3, think about having 3/4. Well, if I have 3/4, I have 75 cents. That's 75%. So quartile 3 represents 75%. And between 25% and 75%, we have 50% of the data. Okay, 50% is in the middle. Okay, because from the minimum to the bottom of the box, I have 25%. And then from the top of the box to the maximum, I have another 25%. So the whiskers here are representing 25% each. That means the entire box is 50% in the middle. Okay? So you need to understand, that's why this measures right here, quartile 1 and quartile 3, helps us know where in the percentile in the box. Okay? This is 25%. The medium should be 50%, right? Because the medium is the middle. And if you think in terms of quarters, in the middle of $1, you have 50 cents. So, with that in your mind, understanding this, you can answer the next question. It says, the box and whisker plot show the hours of television 8th graders watch in a week. So the minimum hours that 8th graders watch is 4 hours. The maximum is 14. So I just like to interpret the box before I start. I know that the box represents 50% of the students. That means that right here is 75%, and right here is my 25%, because that's my quartile 1 and that's my quartile 3, just like the previous box. It says, what percent of students watch more than 8 hours? So from the top of the box to the maximum. What does this value over here represent? Okay, from the top of the box to here. Well, that is 25%. So that would be 25% of students watch more than 8 hours. Okay? Because from the minimum to the bottom of the box is 25%. From the bottom of the box to the top of the box is 75%. And from 75% to the maximum is the leftover 25%. Now, what is the best measure of central tendency for this data and why? So, what is the best measure for us to pick for this box? Okay? So, you have 3 measures. You have the mean, you have the median, and you have the mode. Now, we didn't talk a lot about this in class because this is for your own critical thinking. Which one would be the best to represent the data? Well, it looks like this box is skewed, right? We have more here to the right of the box than we have here So if I was to try to balance this box on a pencil, like if I could balance the box on a pencil, you would have to be somewhere around here to balance the box so the box doesn't tip over one way or another. So if I would have to pick a measure of central tendency, the center of this box, to centralize this box, would I pick the mean, the medium, or the mode? I want you to think about it, and then we can discuss this in class. I'm not going to give the answer in the video. I want you to think about it first, choose which one, and then come and discuss it in class. Think about, you're trying to find the central tendency of the box, okay? So I'll let you think about it, and then we'll come back and discuss it. This next one over here, I also want you to come up with the numbers yourself, and then during our review moment, we'll go over the answers. I don't want to give all the answers here, and this one as well, I need you to come up with the answer yourself, okay? All right, let's move on to another one. Number 5. So you have this scatter plot. Be careful, because we have two things we talk about here a lot. Is a scatter plot and residual plot. There's actually quite a few plots we talk about here, okay? We have a dot plot, we have the box plot, we have the scatter plot, and we have the residual plot, okay? So let me write it down here so we don't get a little bit confused. We have the dot, it's called the dot plot, or we call it the number line. The dot plot is usually a number line like this, 1, 2, 3, 4, 5, and we put dots on the top to show how many times that number appeared, okay? That's a dot plot. And then we talk about the box and whisker. Okay, we were just talking about a box and whisker plot. Usually it's this kind right here. Well, it is this kind right here, okay? That's a box and whisker. Sometimes I just call it the box plot. It's just a short word, so I don't have to always say box and whisker. Okay, and in some statistical books and videos, we also use the word box plot. So you know about a dot plot, you know about a box plot. Now be careful with the residual plot and versus the scatter plot. Okay, so those are also two different ones. A scatter plot is just a bunch of values that there's x's and y's, and we are trying to match them, and we put those values around. This is a scatter plot. In a scatter plot, we want a linear pattern. That's what you need to remember. In a scatter plot, I'm trying to find a linear pattern so I can draw a line between those dots. In the residual plot, okay, you usually have numbers all scattered around, and that's exactly what we want. We want no pattern. We want no pattern in a residual plot. So this is kind of like an abbreviation of the things we have, some of the things we have talked about. Residual plot, we want no pattern. The residual plot, we have to do a little bit of calculation to get it. And the scatter plot is how we match x's and y's, two variables we're trying to match their values, and we're putting here on the scatter plot. Okay? So that's just kind of like a little side note so you don't get confused between scatter plot and residual plot. Okay, back here. We're talking about use the scatter plot to shown to answer the following questions. So let's first look at it before we even look at the questions. We have these dots right here. It looks like lower x values has higher y values. And then it starts, as I go up on the axis, it looks like decreases on the y. So it looks like these dots are coming down here, okay? So they're smaller and smaller as I increase. So as x is increasing here, it looks like the y is decreasing, okay? So what type of correlation is represented by the data? Well, it looks like these dots are coming down, so it is a negative correlation, okay? Negative correlation. Now, what correlation coefficient would be accurate? What would be accurate for a trend line for the scatter plot? So if I was going to put a trend line right here in the middle, okay? If I was to draw a line, somewhere in between these dots right here, because I want to make sure that I get as many as possible. So if I was to draw a line right here, this line has a negative slope, first of all, okay? Because it's coming down is a negative line. So remember I told you the R, which is the correlation coefficient, is between a positive 1, 0, and negative 1. That's the values of R. Well, since I have a negative correlation here, I better make up a R. They're asking you to make up your own. I better make up a number that is closer to -1 as possible. So negative point something. Some of you, I already saw you working your homework, you wrote -0.9. That's okay. Some of you wrote -0.8. That's okay as well, okay? So something that's closer to a -1. Don't write a -1 because a -1, if it was an exactly perfect negative correlation, if it was exactly perfect, then your scatter plot would look like this, okay? 1, 2, it would be perfect lined up. That would be a perfect -1 slope because you could draw the line right on top of it, and that would be a drop 1, run 1, drop 1, run 1. It would have the R that would be a perfect -1, okay? And that would be a perfect negative correlation. That's not what we have here. We have not a perfect, we have somewhat of the dots coming down, so we have a number close to -1. All right? So I'm going to let you answer number 6. I'm not going to answer every single question here. But for the following situation, determine whether the correlation would be, if there would be a correlation, if there is one, is a causal relation, and why. Okay? So I want you to try that one. This one, it is for us to discuss in class. I love the ones that cause a lot of discussion, and that's why we're going to discuss it in class. All right, now this one is 6.5. We just learned about 6.5, two-way frequency table. Okay, I just taught this yesterday, is a two-way frequency table. So let's see what we have here. We have subject, which is ELA, math, and here we have male and female. So those are our two things that we are discussing, our variable and our categories. We have male and female, and we have English, language, arts, and math. Okay, so those are the two subjects. Now, what is the marginal frequency? So I want margin, and I want the frequency, not percentage. When we see the word relative, whenever we see the word relative, that's the correlation we make. When we see the word relative, we think of percentage. Okay? When we see the word relative, that's when we think of percentage. Since there is no word relative here, we're just talking about frequency, how many. And I want the margins. So what is the marginal frequency of total students who prefer math? The margins is the totals right here, okay? The totals. So here are all the students that prefer math. 76 females and 92 males. The total is 168. So the marginal frequency of all the students who prefer math is 168 students. All right? What is the joint relative? Okay, now I saw the word relative frequency. That means this is a percentage. I'm going to have to switch this whole table into a percentage, okay, into a percentage table. I am going to try to fit them right here, okay, on this space. I don't know if it's going to be enough space, but let's try to make the best we can. And I'm going to show you how to create a two-way relative frequency. So I'm going to put the ELA, the math, and the total there, right there. Okay, so these are the ELA, these are the math, these are the total, and these are female, and these are my male students, and this is also my total. Now, how do we turn this into a percentage? I am going to grab every single one of these numbers, 54, and I'm going to divide it by 300. That's how I'm going to get this turned into a percentage. Okay, so all I do here in my calculator is 54 divide by 300, because that's my grand total. That equals 0.18, and then when you switch the decimal over twice, you get 18%. Now I'm going to do that for every single one of these numbers. 78 divided by 300, and that is 26%. And then 132 divided by 300, that gives us 44%. That's how I'm getting that. I'm dividing all by 300. 76 divided by 300. It is 25, it's 0.25333. We're going to write 25%. And 92 divided by 300, we get 0.30666, so I'm going to do 31%. Okay? 168 divided by 300 gives me 56%. Does this add up to 56%? That's what I have to check, because I rounded the 25 and I rounded the 31. Did I round correctly? So that's 5 plus 1 is 6 and 2 plus 5 is 5. I rounded correctly. They should always add up, okay? 18 plus 26, 44. That works. Now let's go to 130. 130 divided by 300, you get 0.433333. Let's just round it to 43%. And then 170 divided by 300, you get 0.566666. So let's do 57%. Does this two numbers add up to 100%? Yes, it does. Does two numbers add up to 100%? Yes, it does. So my table should match coming vertically as it does coming horizontally. It does add up to 100% in each way. Now that I have a relative, which means percentage, I can take my answers from the percentage table. It says, what is the joint percentage frequency of females who prefer English ELA? Okay, so female and ELA. Female and ELA is 18%. Now, what is the conditional? Every time we deal with conditional, you need to go back to the original table. Use the original table, okay? And then you have to observe the condition. The condition always comes given at the end. So given that the student prefer math, only math. So I'm going to write it down, my denominator. My denominator is all students who likes math, okay? Given that that's my denominator, what is the conditional relative frequency that a student is male? So I want all the males, knowing that I can only pick from the students who likes mathematics. So males in mathematics are 92. So I want all the males of all the students. Did I write this wrong? Males, there's an E right there. All the males who are in math. Okay, so that would be 92 divided by 168. All right, so that is a relative frequency because it's a percentage. I'm going to turn into a percentage. 92 divided by 168, that equals 50, it's 0.547, we're going to do 55%. Okay? It is not from this relative frequency table. It will confuse you. Go back to the original. Okay? And that is that's how you're going to be working on your worksheet 6.5. Conditional relative frequency, joint relative frequency, and marginal frequency, or just joint frequency, and so forth. Okay? So that is a pretty good summary of the questions you'll be asked on the test, just like that. Okay? All right. So Jonah practiced shooting 50 baskets from different distances. His data can be modeled by the equation. The equation is given to you, where x is the distance, so x is the distance, in feet, and y is the number of baskets made. Using the equation, how many baskets do you expect John to make from 7 feet? So x is the distance. So they just gave me a value of x. So x equals 7. If I plug that into my equation, y equals negative 2.5 times the distance, which is 7 feet, plus 42, what do I get? I'm going to let you finish that, okay? I'm not going to finish for you. And then now it's 15 feet, so x equals 15. I'll let you plug it in and finish from that, okay? And what type of correlation does this show? You went from x equals 7 to x equals 15. What two values did you get? Are they getting bigger? If they are getting bigger, then that means it's increasing. It's a positive correlation, okay? So the further he goes, does he shoot more basket, or is the numbers decreasing? He shoots less basket. So this is a good discussion for class as well. Okay, question number 8. All right, so let's finish up here so this doesn't become a super, super long video. Does the residual plot suggest a linear model? For a linear model may be the blah, 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 blah. Does the residual plot suggest a linear model may be the best fit for the data? Explain yes, why, or why not. Now remember, we're talking about residual plot, and in a residual plot, I wrote right here 2 seconds ago, in a residual plot, we want no pattern. If there is no pattern, then that is good. That is good model. It is a good model, okay? We want no pattern in residual. So, I'll let you answer these questions. Does that look like we have a pattern here? No. Then that means it's good. Then we'll have a good model. Does it look like we have a pattern here? We have some numbers on the top, and it looks like exactly the same on the bottom. So that is the kind of question you're answering yes or no. And is it because it has a pattern, so it's not good? So I'll let you answer those ones, okay? Okay, number 10. It's probably the last one I'll have time to work on. This one is complete the residual table. I told you residual requires a little bit more calculation. So complete the residual table for the linear equation. They gave us the equation right here. And the predicted value, we have to, let me write a note right here. How do I get the predicted value? Plug x in the equation. Okay, so you plug the x value in your equation so you can get that value. How do I get the residual? The residual is always the y minus the y predicted. Oops, it's not showing on the video, sorry. Is the y minus the predicted y. So this is my y value. I have to subtract the predicted, and the predicted, it has a little y hat over it, okay? How do I get this predicted value, which is this value right here? You just plug in x inside of the equation, okay? So I'm going to do the first few numbers for you. I'm going to plug in, the equation is negative 0.3 times the x value plus 8.7. The x value I'm going to be plugging in is the value of 2, right here in the green pen. I'm plugging in a 2. So negative 0.3 times 2 equals plus 8.7 equals, that means it equals 8.1. 8.1, okay, whoops, doesn't look like 8.1. There we go, 8.1. Let me do it one more time. Negative 0.3 times the x value plus 8.7. The x value this time is going to be a 4, okay, because I'm picking the x values. So in the calculator, you do negative 0.3 times 4 plus 8.7. And I got 7.5. Okay? And you're going to be doing this for all of the x values using your calculator. That's all you're doing. Now, how do I fill up this table? Well, all you have to do is get the y value, which is 6, and you subtract this little predicted value you just found, 8.1. Okay? And 6 minus 8.1, you can do that in your calculator. 6 minus 8.1 is just negative 2.1. And that is your residual value. Okay? That is your little residual value. So, you're going to do the same thing for all of these. Okay? I'm going to do one more. This is 16, because that's my y value. So 16 minus 7.5, because that is the predicted value I found. So if you do 16 minus 7.5, you get 8.5. 8.5. So these are going to be your residual values. So go ahead and finish the table. I showed you that on this side, you're just plugging in the x in the equation given. You're going to get a number, and then that number, which is your predicted value, you subtract it from the original y value. Okay. Now, this is for you to create a dot plot. Okay, so you can label this. It looks like the smallest number we have is a 1, and it looks like the highest number is a 7. So 1, 2, 3, 4, 5, 6, 7. Let's do that. 1, 2, 3, 4, 5, 6, 7. Now, how many times does the number 1 appear? Take a look at it. I see a 1 time here, and that's it. So let me cross it out. That number 1 gets 1 dot. Construct a line plot. I like to call this guy the dot plot. Now the number 2, let's see how many times the number 2 appeared. I see one number 2 right here. I see another one right here. And that's it. So the number 2 gets 2 dots. 1, 2. And then you're going to do it for 3. The 3 happens how many times? The 4 happens how many times? You are literally just putting a dot showing how many times that number appeared. Okay? And then you tell me which measure of central tendency is the best to describe this data. Which one do you think? Does it have an outlier? Does not have an outlier? You decide. Okay? All right. So that should conclude all the questions in your review package. That's 30 minutes worth of video. You guys are the best. Please watch this video. Please review your worksheets. Ask me questions. I left a few blank because we need to have some discussion in class. So do your homework and come and ask me for help. Good luck, guys. You're the best.